Okay. Okay. Suppose this is example number one. Number one, no, number zero, because the motivation is greater than or equal to zero. Okay, and the left-hand side, we have a quadratic function. And in the right-hand side, we have zero. Let's see after see there's no zero what's going on. But okay, this is the idea. So what is the first step? Well, the first step is factorization. This polynomial, no? It's a polynomial, degree 2. And this is super easy. We are doing several times here. That is the reason I don't want distraction with the complicated factorization. 3, 2, negative, negative. Greater than or equal to 0. So this inequality, listen, it's important. It's a combination. We have this sign. Let me copy here. Greater than or equal to. It's inequality. That part is inequality, and that part is equation. Okay, so the solution for the equation is also solution for our problem, no? Because our problem is inequality plus equation. Now, suppose que I solve the equation, que es easy. Temporary, I ignore greater than equal or greater than sign, y I focus in the equal sign. Es obvio que x equal 3 and x equal 2. For sure, this is a solution for our problem and the equal part. Let's focus in the inequality part, greater than. Okay, so let me try to solving that problem using one thing I call classical method. Okay, classical method. We have two methods. The first one is classical method. Okay, in classical method, we suppose, okay, see this expression, let me copy again. I focus in the inequality part. If this expression is greater than 0, so I ignore equal sign because I did before here, right? Now I focus in the inequality part. So this is, see this expression in the left-hand side is positive. That to be greater than 0 is synonymous to say it's positive. It's because this guy is positive, this guy is positive, or this guy is negative, and this guy is negative. Basically, we have four combinations, plus minus, minus plus, or minus minus. However, you ignore that part because you know the positive times negative is negative. So this is the combination that we have. Therefore, we separate the problem and, okay, I try to express it, this inequality in one or in two or in several, in two in this case, compound inequality. So the first one is x minus 3 is greater than 0 and x minus 2 is greater than 0. Because I use in plus plus. Or, okay, the connection is important, the conjunction in the compound inequality. And is this condition and this condition. But we have another possibility case, x minus 3 less than 0 and x minus 2 less than 0. Now, this is a statement, que is a compound inequality, and this statement is another compound inequality, is connecting in the same problem by OR. Okay, by OR. Okay, you don't need to write this, but this is the understanding of this problem. Okay, let's solve it separately. Remember the compound inequality is super easy. What should you solve it separately? Okay, suppose x minus 3 greater than 0. I solve that part first. Is x greater than 3. And that part is x minus 2 greater than 0, x greater than 2. We connecting by and, que and means intersection. Entonces now I like, in my opinion, I consider it super useful the graphic representation for this statement. No? Suppose 0 here, 1, 2, 3. This is 2, this is 3. So this statement is greater than 3. I am doing that construction because I do not highlight directly on the line because I know that this is not the final answer, no? It's the partial answer. And this is the blue part, and the green part is greater than 2. So it's in that direction, no? Exactly the same. Okay, therefore, the connection, o sea, the and connection is the common part between the blue and the green. Es obvio que the common part between the blue and the green is that part. Okay, entonces this is equivalent, this is equivalent, this is equivalent to say que this is x greater than 3, no? Okay, in other words, you represent in interval notation is from 3 to infinity. Pero no, this is the last part. Okay, I'm solving this compound inequality. The partial answer is the yellow part. Now I move on to the second inequality. The second inequality is similar. It's x less than 3. I did that. X minus 2 to say and, sorry, x less than 2. Okay. Representation and the okay. Good morning, Queen. Okay. Entonces is again 0, 1, 2, and 3, no? Okay. That part is less than 3. And that part is less than 2. And the intersection is obvio que es the common part que share both intervals is this. Okay? It's from, sorry, mistake. This is from 2. This is 2. 2. Wow, I select green. Okay, I select green. Okay, so the part share both interval intersection is this. Okay, ready. We are ready to express the final answer. Okay, I did that part. Look, the final answer is this yellow part together, plus, don't forget the equation part is the equal sign. Can include part 2 and 3 inside. So the final answer is parentheses, infinity, negative infinity, that part minus infinity, right? Comma 2, that part, yellow part, but of course include the 2 inside the solution because my problem is a combination inequality and equation. That these 2 belong to the solution. Let's put a bracket. Union, bracket 3, que es the continuation, the bracket here, 3 comma infinity. End story. Do you understand this idea or no? This is the classical approach. Eso, bueno. Betancourt dice, I understand. The rest understand very well or no? Okay. So I want to explain now another approach to solve the same problem. And after I want to discuss advantage and disadvantage of this method. Okay, another way, another possibility. Okay, another possibility. I can see the problem again. Okay. You can see now. Ooh. You can see now. Good. Because I can erase the board. Oh no, because I want to solve the same problem in different approaches. Okay, again, I start at the beginning. Suppose x squared minus 5x plus 6 greater than or equal to 0. Okay, Okay, we're doing the factorization again. This is classic. -2 and 3. Okay, another approach, okay, by the way, the name of this approach is change of signs method. Okay, this is the name. Okay, entonces you factorization again. Okay, no problem. I understand very well. And you temporarily convert my problem to equation. I ignore the greater than sign or less than, depending on the problem. Yeah, I solve the equation that I did before. The answer is 2 and 3. However, this guy is important for me because they are a critical value. Critical value. Critical value is the solution of the equation. This is classical. This is the way that we are doing in calculus. But okay. Either way. So in that moment, I draw the real number line. EI, for example, this is 0 in the middle, 1, 2, and 3. EI create like a partition of the real number. Bam. Yeah, I select, so basically you have two partitions using the critical value. We create partition. And those when you have two partitions, we have three intervals. One interval from negative infinity to 2, one interval between 2 and 3, and one interval between 3 and infinity. Therefore, you select totally arbitrary testing point inside each interval. For example, I select here in the middle 2.5. And you select, for example, 1. And you select, for example, 4. And you evaluate this testing point in the original equation. I want to explain, do a different way. Or you create a chart like that. Look, I like that way. I like, but I do not enforce it to do it my way, you know? You put it here, testing point, and the testing point I select it was totally arbitrary, and I select 1, 2.5, and 4. Another student select another testing point, and the answer doesn't change what testing point you select. For example, testing point 1, testing point 2.5, and testing point 4. So you evaluate, there are many ways you evaluate directly in the spreadsheet, or you evaluate in each factor separately. Suppose x minus 2, x minus 3. Y I attach extra column, calcul total. It's super easy. Evaluate here. For example, 1, you plug it in mentally. You evaluate 1 here. 1 minus 2 is negative 1. So I care the sign, not the value. But the important information for the solution for inequality is the signs, not the value. The value is not important. It's negative. Negative here, again, is negative. And negative together is positive because this factor is multiplied. Negative times negative is positive. 2.5 is positive. Because 2.5 minus 2 is positive, and 2.5 minus 3 is negative, and multiplication is negative. And close in the circle, the sign in the total column because this is important information. And 4 minus 2 is positive, 4 minus 3 is positive, and positive is positive. Okay? So I come back at the beginning. Yeah, I saw, wow, look at that. My inequality is greater than. To be greater than 0 means to be positive. That the positive is the solution, and the negative no. And this problem, guys, I promise que we discussing another problem gets less than. Entonces less than 0. Entonces the true statement is negative. Pero no. In this case, no. Okay. Entonces this is the true. And this is the truth. So this is the testing point that passed the test. And you finally highlight that part. So that part is, look, I consider that interval because 4 passing the test and 1 passing the test. Okay? Entonces you include the endpoint because our original problem is, remember, is no strict inequality, it's a combination inequality and equation. Entonces this is a bracket, sorry, and this is a bracket. And the final answer again we get from negative infinity, comma 2 bracket, union, bracket 3, comma infinity. Another possibility, some students don't like this table. I like this table, pero some students don't. No problema. I understand very well. Some students don't like to say. Another possibility is, in my opinion, yes, Yasmin. Another student, well, okay. Anyway, either way, suppose you create something like that. And you put here a testing point. Okay, 1, 2.5, and 4. And you evaluate the function f of x and this. Who is f of x? Well, f of x is the original expression we have in the left-hand side. Okay, this is our f of x, no? And you evaluate in 1, and you evaluate in 2.5, you evaluate in 4. I did that, and the answer is negative 0.25. Wait. No, sorry, S2, sorry. S2 is positive. It's obviously positive, no? S2. I did that in my calculator. I don't want to waste the time with arithmetic part. 2.5 is negative 0.25. And 4 is 2. 2 again now. 2 again. See, because it's symmetric, yeah. S2. So this is the same conclusion. Look, this is positive. Okay, this is positive. This is negative. Okay, this negative. And this is positive. Okay, this. And we get exactly the same. So either way, guys, you evaluate by pieces using the table, or you evaluate directly on the. By the way, another approach. This is super easy. Well, I want to complicate a little bit, but this is super easy. So you are doing the graph in Desmos of the polynomial. We get the parabola like that. And the parabola like that, you see that the part is over the x-axis is the interval solution because the other part is negative. It's another possibility to verification that we think we are doing is okay. Well, professor, I understand, but I am confusing because we have 2 methods. What method actually we are using? This is the problem. Guys, questions so far? Everyone follow me or no? Eso, bueno. Okay. Do you hear also the raining in my roof, in my ceiling? It's not too heavy. Yeah. It's not too heavy, pero it's okay. Okay. Andreina dice yes. Okay, great. What is the advantage and disadvantage? What is the advantage and disadvantage? Okay, what is the advantage or disadvantage of this? Suppose I don't want to solve this problem, but I illustrate disadvantage of the classical method. Suppose that we have 3 factors. Suppose that f of x is x minus 2, x minus 3 again, pero x minus 4. We have only 3 factors. And this is the inequality, maybe again is greater than or equal to 0. To be greater than or equal to 0, we have several possibilities. We have positive. Well, let me copy every combination. Positive, negative is another possibility. I change one sign. Positive, negative is another possibility. Positive, Negative, negative is another possibility. Negative, positive, positive is another possibility. Negative, positive, negative. Negative, negative, positive, and negative, negative, negative. So we start for the three positive, 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 and we ending in negative, negative, negative. So this column stays the same. Look, this column is only positive, 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 positive. The four first and the last four is negative, 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 no? So how many combinations we have in total? We have a combination, a combination. So actually, what is the combination we are using for solving the problem? One of the combinations we are using for solving the problem obviously is this. Because I know that the multiplication 3 positive is positive. Another is this. Because 2 negative is positive, no? For example, this. And the last one is this. How do you know? Well, easy. You count how many negative we have. See, we have no negative or even number of negative, even. 2 negative, 2 negative, 2 negative, to say it's positive. But actually, to say you have a combination only working with the 4 combination. Combination, plural. And this is too long problem, no? Too long problem. Much better using the change of sign. So in conclusion, when you have 3 factors, it's a combination. Where come from a combination? It's 2 to the 3 power. It's 8. Suppose we have 4 factors, 16. It's crazy doing that way. No classical method. We are using the chain of sign. You determine the critical value. In this case, 2, 3, and 4. Select totally arbitrary testing point and evaluate the testing point using the table, factor by factor, or plugging in directly in the enrichment. Okay? Okay. I suppose that's clear, the idea. Let's go directly to the, I want to illustrate two problems. We make a decision what method we select. And also, I want to study the specific example is much better doing by classical method. Okay? Advantage, disadvantage. Wow, too heavy. Okay. Do you hear very well or no? Okay. Suppose this. This is the example. Actually, okay. This is the example. Example 1 is x cubic plus 2 x squared minus 3x greater than 0. Oh, it's a polynomial. Look at that. It's a polynomial. Greater than no equal. So it's a strict inequality. No equation. Okay, no problem. I do the factorization. The factorization is there greater common factor. Greater common factor is x. I factor out x. I have x squared plus 2x minus 3. Greater than or equal to 0. Now, I can see a trinomial degree 2, and the factorization is xx 3 and 1, no? 3 and 1, because 3 times 1 is 3, and somehow 3 minus 1 is 2. The sign are positive and negative. And this is our inequality I want to focus. Okay, this enclosed in the box because this is important moment, no? Important moment I enclosed in the box, the inequality, no the origin. Okay, now I immediately convert my problem to equation because I want to find the critical value. So I make a decision to apply the chain of sign method because we have three factors. I know it's crazy by the classical method. So I solve this, the solution is 0, the solution is -3, and the solution is +1. And this is our CB. CB means critical value. And critical value I am using to create a partition of the all real number line. Look at that. Infinity positive, infinity negative. 0 in the middle, partition. -3, -1, -2, -3, -3, another partition. 1, +1, another partition. 3 partitions. And you select totally arbitrary testing point, totally in each interval. Actually, we have 1, 2, 3, 4 intervals, no? I select in my paper -4. I select in my paper -1 here. I select in my paper in between 0 and 1 half, positive half. Then I select in my paper positive 2. Okay, suppose another student select 3, 4, 5. It doesn't matter because the behavior of the testing point is the same inside the specific, the corresponding interval. Yeah, I create the chart like that. TP, testing point. I put the testing point, -4, -1, positive half, and 2. And the factor involved in my problem are x, doesn't matter, the order is not important, guys. X plus 3, you copy in other order and evaluate, it's the same idea. Because the order is not important in the multiplication. And don't forget the total column is important. And remember, you evaluate one by one into the factor, and you discover the sign. I don't care the value. The sign is important information. When it's obvious because this is negative, no? Negative, positive. This is obvious, right? When you evaluate directly in x, it's the same sign that we have here. But a -4 is negative. And -4 is, bueno, es -4 plus 3 es -1, ¿no? And -4 minus 1 is -5, es minus. The 3 minus, the total sign is negative, no? Because minus times minus times minus. The clue of the identification is you have even number of negative, okay, is the conclusion is positive. So you have odd number of negative, the conclusion is negative, ¿no? Entonces, the control of this table is given by the negative. The positive is a little bit stupid. The positive is not important. Well, it's important, but not extremely important. The -1 here is positive. And -1 here is negative. And the answer is positive because we have 1, 2. Okay, super. Now plus, this is plus, and this is negative, no? And the answer is negative. And finally, when this is plus, because it's 2, and this is plus. So I come back at the beginning. At the beginning, say que my inequality is greater than 0, que sinónimo to say to be positive. And to be positive is this guy. This is true. I put the word true to indicate solution. You can put the word false to indicate no solution, but it's not important. I don't like this. This is my way, guys. You will using your common sense and your imagination. So the interval solution, okay, what testing point pass the test? -1 pass. Okay, entonces -1, this interval belong to the solution. And one more interval is from 1 to infinity. From 1 to infinity. Okay, 1/2, do not pass the test. And -4, no. And the rest is just parentheses. Parentheses, parentheses, parentheses. Okay, super. So what is my final answer? The final answer is final answer. Final answer. Colon -3,0 union 1, infinity. Be careful, be careful, be careful, because remember, some students confusing with the testing point. The testing point is not important. The testing point is totally arbitrary, guys. However, my interval start in -1. Of course, do not include the -1 because these problems have no equal sign. No equal sign don't include the endpoint. But some students confusing with the testing point. No, the testing point is crazy. Another student select 3, another student select 4, and you get the same result. And it's the final. Any question, guys? Yeah, for sure, for sure. Not always happen. Wait a second. Not always happen. Depending on the problem. Suppose, Mister, I change that problem like that. Look. Suppose I change that problem like that. I put less than. Of course, this is another problem. It's another problem. The true guy is the name. And the solution is totally the complementary part. Okay, do you understand? So depending the original problem is greater than the true is the positive. Is less than the true. Is it clear or confusing? Come on, I want to hear opinion. Little by little. Little by little, you clear. Little by little. Guys, this is just the beginning. I promise you this is more complicated. To understand, please.
I have a question. So, can you hear me?
Yeah.
So for the to chart the line thing, do we have to do that? Can we just go straight to doing the graph, the chart thing with the TP and all of that, or do we have to do the thing with the numbers at the top?
Okay. So the procedure is clear. You have critical value. Critical value allow you to do a partition in the all real number line. After when you have partition, in this case we have 3 partitions, three partitions. So we have 3 critical values. Now you split the entire number line in 4 intervals. 1, 2, 3, and 4. And you pick totally arbitrary testing point inside. And you testing this using the table. And the total column, you see it's positive, it's true. Because our original problem was greater than. Okay? Some testing point passed the test, and another testing point failed the test. And you take the testing point get past the test. Now it's clear? Yes. Okay. Guys, I do annoy the noise of the raining because I can switch into the. This is not good for me because I have another room, no? Not my office. Do you want I do or no? Is hard the noise or no? Hard or no? Yes. No. Yes or no? It's hard. Okay. I switch it. Don't worry. Be happy. Be happy. Wait a second. Mouse. Okay, no noise. No, oh yes. Do you hear something or no? Let me know. No noise. Okay. Do you understand, guys, why it's important to be a building for the college? Okay, it's important. I remember something in the college. We have a store. However, it's different. You know, sometimes happen in the college we have no internet. Okay, but it's different. It's face to face. Okay, don't worry, be happy. Let's go to the example 2. Pay attention to example 2 bring me new situation. Totally different. Example 2 is x to the 4th power greater than or equal 4x squared. And it's given like that. Solve this inequality. Wow, professor, I don't understand anything. Because, well, no, I understand. This is inequality. Look, an equation. Okay. But what is the problem? The problem is that the right-hand side is not 0. And this is mandatory to be 0. Okay, the first thing you should do, listen up, it's important, is manipulate the expression in order to express the right-hand side like a 0. This is important. Right-hand side must be 0. This is extremely important. Why is it extremely important? Because the comparison that we are doing in the table, remember, plus, minus, plus, minus, plus, minus, plus, minus. But this plus, minus is with respect to 0. Like you say, it's positive or it's negative. So this is, you compare with the level of the C is 0. So any problem we have to solve, you need to manipulate in order to express the right-hand side 0. So like that, f of x greater than or equal to 0, or f of x less than or equal to 0, or f of x greater than 0, or f of x less than 0. This is the fourth possibility of the problem. But right-hand side must be 0 mandatory. Otherwise, you are in big trouble. So sometimes, now it's clear. I suppose it's clear. But sometimes no, it's not clear. Sometimes it's confusing. And the students don't know very well manipulate. Don't forget, right-hand side must be 0 in this problem. Always. Now factorization. The common factor is x squared. Factor out. Oh, I can see now a difference of a square. So it's x squared. It's a difference of a square. The classical formula of the difference of a square, 2 factor, xx, 2 plus or minus. Okay, and this is, I focus it in this. No, in the original. The original is totally useless. No good. No good. I focus in this after the factorization. A mandatory right-hand side must be 0. Okay, what should I do when I make a decision again to do by the changing sign method? No? So I determine the critical value. The critical value is super easy. You convert temporary this inequality to equation. And the solution is x equals 0. Well, actually is, okay, this is the multiplicity, no? It's a polynomial, degree 4, by the way. And so because degree 4, look at that. degree 4. And we have 4 solutions, no? X equals 0 is multiplicity 2, but I don't care. I don't care. And also multiplicity 1, negative 2. Let me separate by comma and positive 2. And this is my critical value, okay? I use it to make a partition of the all real number line. Okay, okay, the procedure is always the same. Suppose that the inequality after the factorization is equation. You determine the critical value, get the solution of the equation. Using this critical value, you make a partition. And selection testing point in each interval. Okay, for example, negative 3 is good. Negative 1 is good. Positive 1 is good. And positive 3 is good. Okay, ready. And you try to plug it in into the expression or doing factor by factor using the famous table. No? Okay. Testing point. Testing point R minus 3. Each testing point represents a row of the table. Negative 1, another row. Positive 1, another row. And positive 3, one more row. The factor involved in the problem are x squared, x plus 2, and x minus 2. And don't forget attach new column, que es the most important column, que es the total. Okay. But I bring this example to illustrate very well one new idea. The first column gets x squared, always is positive, yes or no? Because it doesn't matter, regardless if the number is negative or positive, when you square become positive, no? Entonces I explain that the positive is not important in the analysis. The most important is the negative. When you have even number of negative positive or odd number of negative is negative. But I never say the participation for the positive. Therefore, okay, there's no control anything in my inequality. Therefore, we can eliminate this column. Whoa, professor, but what the hell is that? I don't understand. Okay. When the exponent is even, when you have factor, multiplicity 2, multiplicity 4, multiplicity 6 even, we can ignore. We can ignore totally in our inequality. This is not totally 100% true, but in this example, yes, it's 100% true. I want to discuss in detail more clear how you delete or partial delete this fact. But in this example, yes, for sure, we can totally delete because of positive. Y I focus only in the other factor, que es el factor que control the sign. So this is a negative 3 is negative. Is negative again because negative 3 and negative 2 is negative 5. And it's positive. And it's positive because 2 negative, even number is positive. This is positive. This is negative. This is negative. Because we have only one negative, no? This is positive. Because it's 1. This is 1 and negative again. It's negative. Okay. And this is positive, and this is positive, and the answer is okay. I come back at the beginning. My inequality is greater than or equal, but I don't care the equal. It's greater than. That means that the true guy is the positive. And the positive is this, and the positive is this. Okay. So my solution is okay. The testing point that passed the test was negative 3. Look at that. That interval. and positive 3, that interval. And what about the endpoint? The endpoint is also part of the solution because my problem is a combination inequality and equation, equal sign. Okay, therefore, the critical value is also belong to the solution. And what is the symbolic way to indicate this idea? Well, the symbolic way to indicate this idea is using bracket here. Wow. And what about 0? 0 is totally isolated point in the middle, but belong to the solution. Look at that. Okay, Professor, well, how you write the final answer? Well, the final answer you write like that. Let me show you. You write like that. It's from answer. It's from negative infinity, comma negative 2, bracket, union. Doesn't matter the order. But from left to right, I put 0. 0 is only one isolated point. And we use in the curly bracket. Remember, when you solve the equation, for example, when you solve one equation, the solution is 1, 2, 3, or 0 or negative 2. So the solution, you indicate 0, comma negative 2, comma positive 2, no? This is the way to indicate solution set of the equation because there's no intervals. One isolated point in the middle of the line. Union, bracket 2, comma infinity. Okay, this is my final answer. My final answer. So in this example, you see important detail. The important detail is number 1, to solve any inequality of this, we need to create right-hand side 0. Number 1. Number 2, when you face one factor, okay, the exponent is multiplicity even, like a 2, like a 4, we can delete because they are always positive, and the positive do not control the total sign. Only the negative control the total sign. And the rest, well, sometimes happen that the solution is interval, okay, highlight in yellow color, and one isolated point in the middle. Any question, guys? Any question? No? Oh, okay. And this is the moment, okay, I want to explain one thing, que allow me to understand much better the idea in what case I need to use, for example, the classical method or the changing of sign method. Okay, look. I studied before. When the exponent is even, you delete. No, this is not totally true. Let me explain in detail this idea. Look at that. Suppose we have, okay, this is like I call a special case. A special case. Suppose this is inequality. X minus 2 square greater than or equal to 0. Entonces, suppose que I need to solve this inequality. Okay, nice. The right-hand side is 0. Good. I take advantage of this. But x minus 2 squared. Wow. Entonces, es todo que cuando el exponent is even, you can delete. But let me try to understand more clear this idea. Okay, this is a parabola. Okay, remember, and we have transformation. What kind of transformation we have, guys? We have horizontal shift to unit to the right. 1, 2. This is my parabola. Look like that. And you can see clear, like a water, that this parabola is always positive, or 0 and 2. Entonces, the solution for this inequality is all real numbers. There are no problems. So that is the reason this do not introduce restriction, and we can delete, totally delete. Do you understand the idea? Because the parabola is always above the x-axis, the y value is always positive. What happened? What's going on if you have x minus 2 squared greater than 0 without equal sign? No, it's not all real number. It's not all real number because specifically n2 is 0. Look at that. So 2 minus 2 is 0, and 0, you plug in x equal to here, 2 minus 2 square greater than 0 is 0, 0 squared is 0, and we have a contradiction, right? A contradiction. This is totally false statement. Therefore, this is, okay, so now, when you have that situation, when you have this inequality, look, when you have this inequality, and this is equivalent to say, no real number is x no 0, no 2. Oh, because it's all real number except 2, and 2 we have a whole. Okay, so what is the procedure that we are doing? Okay, suppose que we have inequality like that. Suppose x minus 5, x minus 4 squared greater than or equal to 0. We continue doing a special case. So immediately I realize, wow, we have exponent 1 here, yeah, and exponent 2. And the professor explained me when you have exponent 2, you can delete. But in this case, it's totally delete or partial delete. Okay, delete, totally delete is when the my inequality contains equal sign. So you totally delete, and this is equivalent. This inequality is equivalent to say only x minus 5 greater than or equal to 0, x greater than or equal to 5, and the solution expressed in interval notation is bracket 5, infinity. End the story. Wow. Not necessarily apply changing sign method. No. When this is special, you delete or partial delete, depending on the problem. Suppose que I have exactly the same example, but this no equal. It's only greater than. So I realize in that case, when this no equal, you partial delete. Partial delete means that you take x minus 5 greater than 0, this, so you take this greater than 0, and this delete, pero partial delete, how? You introduce and no 4. And no 4. Similar to this. And no 4. Okay. So then 4 we have a whole. And 4 we have a whole. Okay, no problem. I understand. Okay, entonces you solve this inequality, get x greater than 5, and x is no 4. Let me try to understand this compound inequality. Okay, x here, this is 0, 1, 2, 3, 4, and 4 we have a whole, and 5 is greater than. Greater than means is parenthesis in that direction. And the whole is completely outside the interval. So this is equivalent. In this case, a coincidence. Depends if the whole is inside or no. But in this case, outside the whole. That the whole is not important. So is the solution, the answer of that problem is parenthesis 5, because 4 is totally outside the game. Guy, do you follow me? Do you follow me? Okay. The thing I try to explain now, the new thing is that we have some special case. And the special case that we have is extremely easy for solving, not necessarily complicate your life doing the big table with the all testing point. No. Okay, when you have factor, okay, the exponent is even, you have two possibilities, or totally delete or partial delete. How do you know when it's totally or partial? See, the inequality is a strict inequality, you partial delete. So see, the inequality have no equal sign, so it's partial delete. And you consider like a whole, the factor involved, so in that case 4. si the inequality is no strict inequality, it's a combination equation and inequality, entonces you totally delete. Let me see another example. It may be clarify this idea. We continue working in the special case. Suppose x minus 3, x minus 4, again 4 square greater than 0. Okay, I face that problem. I can see now the factor que contain exponent even. Entonces you, in this case, delete. Pero es partial delete o es totally delete? What do you think? What do you think? Totally delete, partial delete. Totally delete, partial delete. No answer. You understand or you don't understand very well this? Es partial. Align, rename. Say it's partial. The reason it's partial because it's not equal here. When you see equal here, automatically totally delete. But no. It's no equal, entonces partial delete. Partial delete means que you copy, this is equivalent to say x minus 3, que es the factor que contain exponent 1 greater than 0, and you introduce a whole, que whole is in 4. Okay? Now, let's do it. Okay, the solution for that part is s greater than 3. This is 0, 1, 2, 3, and 4 we have a whole. But in this case, the solution is from 3 to 4, and for 4 to positive. So what is the final answer? Well, the final answer in interval notation is parenthesis 3, comma 4, parenthesis union 4, comma infinity. This is the answer for this inequality. Do you understand the idea? Confusing, very confusing, very clear. But I have more case specific. Come on, guys. This is the moment to ask me any question. No? Everything is okay? Kind of confusing. Okay. Let me summarize. This is important, Jasmine, you understand. Okay. And you delete when it's square. Yes, I delete not necessarily square. I delete when the exponent is even number. Suppose. But let me erase the board. And now it's not raining. I go to my office again. Suppose that we have this example. Let me try to do this. X minus 1, x minus 2, square, x minus 3, and x minus 4 raised to the 6th power, greater than or equal to 0. Suppose that you face that problem. Even. Totally delete or partial delete? Totally delete. How do you know it's totally delete? Because it's equal. So my problem, this problem, complicated problem, is equivalent to say x minus 1, x minus 2. End the story. And you solve this super easy, in either way, with the classical method or the changing sign method. Either way. This was totally delete. How work partial? Suppose exactly the same problem, the same factor, but now it's greater than, no equal. So the only thing I change is equal sign. So this is partial delete. Entonces, you partial delete this. Let me copy, bueno, like that, okay, partial delete. Entonces, this is equivalent, this problem is equivalent to say x minus 1, x minus 3, greater than 0, and we have to hold into and 4. Okay? And so when you solve this, you can do by change of sign or no, you consider in the all real number line here in 2 and 4, we have a whole. End the story. Any question? More clear now? Eso, I get that. Okay. Okay, I mean, look, but unfortunately, we have more cases. Okay, guys, I take advantage to switch in again to my office because now it's not raining, huh? Wow. In my office, I have the more conditioner. I have another computer. I want to send when the class is over. I want to send the review package for the test too. Okay. Let me connecting the power supply for the laptop. Let me bring the mouse and selection. Okay, ready to continue. Do you hear me very well or no? We continue. We continue with the special cases. We continue with the special case. Suppose we have this inequality. Look at that. X to the second power plus 4 is greater than or equal to 0. Okay, professor. Suppose we have one factor like that. And one factor like that to see graphically is a parabola again. But in this case, we have vertical shift 4 units up. Okay, this parabola is 1, 2, 3, and 4. You see that the parabola is like that. This is x-axis. This is y-axis. You see that this parabola is always up above the x-axis. So this guy is always positive. And make it sense. It doesn't matter if you plug any negative or positive here. Square become positive plus 4 is always positive. Now, the solution for this is again all real number. Regardless, look at that. Si es x squared plus 4 greater than 0 is exactly the same because 0 is not important because this parabola never touch the axis, never touch the x-axis. Okay, so in this case, when you have one inequality que incluye this, suppose x minus 1, x squared plus 4, or plus 2, or plus 3, x minus 3, greater than 0 or equal. Doesn't matter si it's equal or no. You totally delete this guy. Totally delete. Okay, this is, look, it's important that you see the differences between this and this. Suppose x minus 4 squared, x minus 3. In this case, you partial delete. In this case, totally delete. And we have another factor, que es similar. Suppose another factor que es x squared minus x plus 1 greater than or equal to 0, or x squared minus x plus 1 greater than 0. This is also parabola. But this parabola never, when you try to understand, see this parabola cross or no, see we have x intersect or no of this. Remember, well, in this case, quadratic equation is super easy. You can compute discriminant. Remember, discriminant is b squared minus 4ac. If the answer is negative, it's because the solution for this quadratic equation is complex or imaginary. In that specific case, b is -1. A is positive 1. Well, everything is 1. Except B is negative 1. And C is positive 1. When you compute the discriminant, it's negative 1 squared minus 4 multiplication by 1 multiplication by 1. So it says 1 because negative 1 squared positive minus 4 is negative 3. And negative 3 is negative, and when the discriminant is negative, because this parabola, no. By the way, this parabola, I don't want to waste the time, but this parabola never crossed the x-axis, and the vertex, by the way, curiosity, is 1/2, 34. Okay? So when you see that, you testing, see this expression. This is irreducible quadratic expression. This expression never crosses the x-axis. Therefore, this guy do not affect. So you totally delete in the inequality. Okay, another special case. Wow, two special case. Too much special case. Suppose that we have x minus 5 to the cubic power. Greater than or equal to 0. What is the equivalence of this? Well, I eliminate the cubic, x minus 5 greater than or equal to 0, right? Because this exponent is odd exponent. Okay, when you totally delete something, what is the answer? Well, the answer, when I totally delete, when you totally delete, the answer depending the rest of the remaining factor. So you delete, in this case, the answer for any problem that we solved before is a real number, because I have only one factor que totally delete. But in the real life, we have several factors. The factor gets deleted. Well, this is history. It's go away. Now the factor gets stay, determine the final answer. Okay, miss? Okay, look. Do you understand very well that I can remove this tree and nothing happen? Do you understand that I can delete this tree and nothing happen? Okay. Let me try to visualize this idea. In my mind, I break it down this like that. And that, I like that. If this is even, totally delete. And this is exactly the same. Okay? We have another case. Okay, I have here. I have a plenty problem with this. Okay, suppose another example. Suppose another example gets something like that. This is special also, guys. Special cases. Look. Suppose we have this inequality. X cubic greater than or equal 125. Okay, solving this inequality. Well, the first thing you should do is remember right-hand side must be 0. Okay, now I focus in the factorization of this. This is the difference of cubic. I want to recall the formula. So you don't remember, the formula for the factorization is something like that. Okay, so this, in our specific example, we have two factors. One short, que es the binomial, one long, que es the trinomial. Entonces, the cubic root this is x, and the cubic root 125 is 5. And minus here because this is a minus, this is minus, and this is minus, no? In the trinomial part, we have a squared, but a is x squared, plus multiplication of a and b together, que es 5x, plus square 25, square 5 que 25. No? So actually, the only thing that we are doing is algebra. We are doing algebra. I move 125 to the left-hand side, I do the factorization. Entonces, this is a moment to analyze this factor. Okay, this factor sound like a special. And I know it's special because the solution of this, okay, what is the reason the formula stop here and do not continue factorization this trinomial? The reason is because this is prime. This trinomial is prime. And this trinomial is prime because the solution is complex or imaginary. Let me prove. In this example, A is 1, B is 5, and C is 25. In this, A, B, C. And you apply discriminant, que es B squared minus 4AC. Discriminant is 5 squared minus 4 multiplication by 1 multiplication by 25. Entonces, D es 25 minus 100, wow, es minus 75, que es negative. Si es negative, that means que the solution for this is complex. In other words, this parabola never cross the x-axis. In other words, this parabola is always positive. Therefore, we can totally delete in the inequality. And we have x minus 5 greater than or equal to 0. You solve this elementary inequality. And that's it. It's x greater than or equal to 5. And the solution is present interval rotation is bracket 5, infinity. End the story. Do you understand very well this or no? Maybe today is the day to study special. And we practice 1, 2, 3 problems, combine everything, no? It's the most complicated part. But we have tomorrow. Tomorrow, no. Next time to continue this topic, no? To see more clear, everything clear. Okay. We have to special K more. Do you follow me, the last one? The last one was clear or no, or confusing? Okay, basically, try to guarantee right-hand side 0. This is mandatory. Okay, special case because D is negative. Yeah. When D is negative means, when D is negative means que this parabola will never cross the x-axis. Okay, it's always positive. It's always positive. So this do not participate in the game of the inequality. Because the inequality, remember, I need to investigate where the guy can become negative. Negative is down. Okay. Let me erase the board. Okay. Suppose one couple of problems, que similar. Suppose 5, because I want to complicate not only polynomials, rational. Suppose this inequality. And suppose why no, this inequality. Minus 3 over x plus 7. Less than 0. How you solve this inequality? Wow. How you solve this inequality? Some people make a mistake to create to do cross multiplication. This is totally wrong. So in the inequality, we cannot do never cross multiplication because I know that the student lie and try to do. This is a moment you fail. Because remember, in the inequality, when you multiply by positive, the inequality sign stays the same. However, when you multiply by negative, the inequality sign is switching, reversing. Okay? So what is the sign? No, see, I have no idea what is the value and what is the interval, is positive or negative. So you have no, impossible. But I take advantage, get right hand side is 0. This is good. It's 0. In both cases. My question is, we can delete this 5 or no? We can delete this 5 or no? We can delete this 5 or no? This 5 is gone. and you convert this to x plus 2 greater than 0? Yes or no? Yes or no? It's possible or impossible to do that? What do you think? No. Yasmin dice, no, it's illegal, totally illegal. Okay, Yasmin, let me try to understand. 5 over x plus 2 greater than 0. But 5 is a positive number, right? And remember, the positive is not important in the inequality. To be the entire expression to be positive is equivalent to say that this is equivalent to say to be positive. See, 5 is positive is because x plus 2 is also positive. It's the only possibility we have. So when you have expression que contain numerical value, you analyze, wow, this number is positive. Yes, delete. Delete because it's positive. Okay, totally. Delete. Okay, okay. And what do you think about the second example? Let me clarify the second. The second example is minus 3 over x plus 7. Less than 0. We can delete this guy or no? Yes or no? We don't delete. Well, yes and no. The answer is no, but we can. But we can doing this new idea. When you see that you have numerical value and this value is negative, we cannot delete because the negative is important, right? The positive, no. The positive is totally useless, but the negative, no. The negative is important. But if you multiply by -1, both sides of the inequality, then we have 3 over x plus 7. The -1 times 0 is 0, but you know that you need to reverse the inequality sign when you multiply. When you multiply both sides by -1. Now we are ready to eliminate that 3, yes or no? We are ready to eliminate these 3 now? Yes, we are ready to eliminate these 3. So actually, this is equivalent to say x plus 7 greater than 0. Another point of view. The original inequality is less than 0. This is equivalent to say to be negative. Entonces, si this number is negative, this must be negative because I know that negative divided by negative is positive. Sorry, it's positive. The negative divided by positive, I know que es negative. When you multiply both sides by -1, you change the sign. Yeah, absolutely. When you multiply not by -1, by any number, when you multiply by negative number, one inequality, I want to prove. But the important thing was, in order to remove the negative sign, because I don't feel comfortable with this negative, you multiply left and right by -1. So it becomes positive. But I have to mandatory reverse it, this sign. So now it's clear that this is equivalent to say that the denominator expression is positive, is greater. Okay, another point to check it out. See how you're doing okay, or there are contradiction or nonsense thing. Look, this guy is negative. This guy is negative. This guy is negative. This guy is negative. To be negative, because this is less than 0, to be negative, to say negative divided by positive is negative, no? Therefore, it's equivalent to say que x plus 7 is positive, que it's equivalent to express it like that. Okay? And we get the same conclusion. I prefer to organize my mind. I prefer delete the negative number. So I multiply by -1, I get a positive, and I know that the positive number is completely useless. No important. It's no important. It's no important. It's no important. Okay, guys. Let's doing a couple And the rest of the time we have, let's do a couple. Let me try to find good example. I have a lot of plenty examples. I try to find one important, one is elegant. Okay, I like that. 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 Okay, I like that. Okay. Okay. Let's go directly to example. In this example, I have no idea si you need to delete something or no. Okay, let's see it throughout the game. Okay, suppose this inequality. 1 over x plus 2 greater than 3 over x plus 1. Solve this inequality. That's it. It looks like easy. It's no big deal. What should I do? Well, always right-hand side must be 0. It's totally stupid. Totally stupid. Apply cross multiplication like that. 1 times x plus 1 is x plus 1. And 3 times this is 3 times x plus 2. But what is the sign here? Is greater than, stay the same, or is less than? No idea. No idea. No idea. No idea. Si you try to solve it, you don't know si the solution is positive or negative, or it's both. So this is completely crazy. And some people try to do anytime. No, 0 for you. Okay, remember, important. Right-hand side must be 0. This is the most important moment. Right-hand side must be 0 to start any problem of the solution of the rational polynomial inequality. Okay. Now, normally, and the problem we see before, we are doing factorization, but in this case, no, because it's a rational. So it's a rational. You try to condensing this and this together in only one compact fraction. Okay, entonces the least common denominator is both x plus 2 and x plus 1 together. And the top we have, well, this divided by this, eliminate x. You divide this, you divide the least common denominator by each denominator one by one, a multiplication by the corresponding numerator, no? You divide, stay alive, only x plus 1 times 1 is x plus 1. Minus 3 times x plus 2. I suppose that you understand this algebra because it's elementary, right? Yes or no? Do you understand this algebra? Okay, now distribute the property. Okay, we have x plus 1 minus 3x minus 6 over x plus 2 multiplication x plus 1. Don't forget, complete the inequality, no greater than 0. And we combine later. So positive 1 is negative 2, negative 2, negative 2, negative 2x, negative 2x, and minus 5, and minus 5, and minus 5 over x plus 2 and x plus 1 greater than 0. Wow, okay, this is perfect. We can work using this. However, I don't like. Why I don't like? Because I have too many negative here. Maybe it's not comfortable to understand for me. And maybe you multiply both sides by negative 1. See, when you multiply by negative 1, this becomes like a 2x plus 5. Nice, I like. This stays the same because I multiply only 1. So I make a decision, multiply the top part. Well, multiply the top part. And only 1 negative 1, not 2 negative 1. And this stays the same. And 0 multiplied by negative 1 is 0, but you have to reverse it the same. Okay, for me, this is more clear. More clear, right? Everyone follow me so far? This algebra is clear or is confusing? This algebra is clear or is confusing? Answer me, please. Are you boring? Are you there? Okay, clear. Okay, super. Now, how many factors we have involved in my problem? We have 3 factors. 2x plus 1, 2x plus 5, x plus 2, and x plus 1. Entonces it's crazy doing by the classical method. I prefer chain of sign. So you determine the critical value. What is the critical value? Critical value is the 0. Critical. Critical value is zeros. But 0 of what? Of the top or the bottom? Both. Both. So you copy 2x plus 5 equal to 0. It's 2x equal minus 5. Divided by 2 both sides, es negative 5 over 2, que es negative 2.5 in decimal, no? I put in decimal to see much better, right? When they're doing the partition of the whole real number line, no? And x plus 2 equal to 0 is negative 2. And x plus 1 equal to 0 is negative 1. Okay, so using this, and this, I make the partition of my famous whole real number line. Okay, look at that. This is 0, everything is negative. So this is the most important part, negative 1, partition, negative 2, partition, and this is negative 3. But the partition is a minus 2.5 here. Minus 2.5. Entonces, in my paper, I select. When we have 3 partitions, we need to select 4 testing points. And the testing point I select in my paper was negative 3, and between negative 2.5 and negative 2, I select negative 2.3, or 2.1, or 2.2, or 2.4, either way. And between negative 2 and negative 1, I select negative 1.5. Y after negative 1, I select 0, 1, 2, 3, 4, 5. I select 0. This is my testing point I propose in my chart. Okay, TP. I organize my table like that. I have minus 3. I have minus 2.3. I have minus 1.5. I have 0. The factor involved in my problem was 2x plus 5. The order is not important. X plus 2, x plus 1, and you create the last column, the column in which you summarize everything, total. I call total. And now you little by little slow down, you substitution negative 3 in each expression. Bam, 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 bam. When you substitution negative 3, 2 times negative 3 is negative 6. And negative 6 plus 5, negative 1. No, this is negative. Negative 3 is negative. And negative 3 is negative. 3 negative become positive. Become negative, sorry. Because it's odd number of negative, no? 2.3 here, 2.3. I put in my calculator, 2.3 times 2 is 4.6, negative 4.6. Plus 5 is positive. It's obvious it's positive. It's obvious it's positive here, it's positive here, right? You can do simultaneous if you want. This is negative, because negative 0.3 is negative 0.3, but this is positive, and this is positive. And 2.3 here is negative, and positive. So this is positive, this is negative, and this is positive. Okay, so I come back. No, at the beginning. No. Remember, we manipulate algebraically our inequality to this moment. and this is the most important moment I highlight or I enclose in the box. And to be less than 0 means that the true guy is the negative. Okay, entonces this is negative, this is true, and this is true. And the rest is false. This is for I don't care. If I don't care, I don't put anything. Now, what's the final answer? Well, what is the testing point que pass the test? Well, negative 3 pass. So this interval is okay. One more, 2.3, no. 1.5, yes. So this interval is in between negative 2. So the interval is bounded by the 2 critical value. Okay, and that's it. Because 0, no. 0 failed. Okay, so what is my final answer? What is my final answer? My final answer is then from negative infinity. Final answer is from negative infinity, comma 2.5. And doesn't matter if you put in decimal fraction 5/2. And the issue is include or do not include this endpoint. The bracket or parenthesis. Well, at the beginning, I can see that my problem is strict inequality. Do not consider equal sign. So when there's no equal sign, it's always a parenthesis, never bracket. Union, minus 2 comma negative. Finance. Any question, guys? Any question? Any question? Any question? Any question? Any question? No? Okay. Okay. Well, I propose you do one more. And the rest, okay, immediately, please help me when I want to do one more. Weird, a little bit weird. Que apply everything we've done so far. And also, immediately, I will send to you the review package, because my goal is next class, so third day, we continue doing one couple more of the example of this, and immediately we start the review for test number 2, because it's too long review. I don't know why I create long review. Okay. So I will say, and you stay here and confirmation with me si you receive or not. Okay. Okay. Suppose this example is the last one for today, because x plus 12 over x less than 7. Wow, what the hell is that? I need help. Help me, please. What should I do? Help me, please. What should I do? What should I do? Okay, do you understand that this inequality is different to the inequality we at the beginning, because it's no linear. So we have linear, it's super easy. It's just algebra. In this case, no. In this case, we need to do something different. No? What do you recommend me doing that? What do you recommend me doing that? No idea, guy. I lost. You're lost. Make it 0. Yeah. Yasmin say make it 0. Okay, make it 0. Yeah, you are right. Right hand side must be 0, guys. Mandatory to start. It's mandatory. Okay, but Yasmin, I recommend first of all you express it, that part. Doesn't matter the order. Like it, using one only compact common denominator x, no? Entonces x squared plus 12 less than 7. And finally, the most important moment, look. Move 7 to the left Yeah, I have that. But leave it like that, no. Of course, no, because to start the critical value, and the partition, everything, now you need to express it no in two pieces. No, 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 no. And only one compact piece. So I propose you, again, you suppose that 7 is a whole number, denominator is 1, the least common denominator is x, and we have x squared plus 12 minus 7x. Oh, much better. Much better, at least for me. Okay, leave it like that. No, 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 because I want to organize this trinomial in that way. At least for me, it's much better to see and factorization. In this case, possible. In this case, 4 and 3, no? Because 4 and 3, 4 times 3 is 12. And somehow, 4 plus 3 is 7. Okay, mine both, no? Wow, and this is fantastic. And this is expression I want to focus on to solve the problem. No, the original region. So basically, you expect in the test, okay, you need to manipulation. So the inequality is given in the test is not ready to analyze. No. You need to manipulate. You need to manipulate. Apply some algebra. Don't forget to express the right-hand side 0 and factorization. Entonces, when the factorization is done, well, entonces you are ready to determine the critical value. Es obvio que the critical value in the top, critical value. The critical value on the top is 4 and 3. Yes or no? And the critical value on the bottom is 0. In conclusion, we have expression. We have the rational expression, and you consider that the critical value are the 0 of the top numerator and denominator. Okay? And this critical value always help me to are doing the partition of the all real number line. Do you understand, guys? In the test, you make a decision to do the solution for the problem using the changing sign method. The solution contains one algebra part and one graphic part. I want to see both. I want to see the table. So you make the decision, no? No, you can do in different way using the classic method. But the disadvantage is that we have 3 factors: x minus 4, x minus 3, and x. Remember, we have a combination, and for each a combination, we select only 4 can give me negative value because it's less than 0, no? Entonces, I don't like this, I like that. Si I like that, therefore I need to see the graph. Entonces, the 0 is here, suppose. 1, 2, 3, and 4. We have partition in 0, we have partition in 3, and we have partition in 4. And we select one testing point, it was -1. I don't know why I select -1. Another student select -2, -3. The behavior of any point after this, before 0 is the same. And between 1, 0, and 3, I select 1, 2, 3. I select in my paper 1. Another student select 2, 2.5. And between 3 and 4, absolutely, I select 3.5. And after 4, I select 5. Not necessarily. Some people say, well, professor, how do you select that? Either. Okay, do you need to understand that this interval represents like a country? And you pick one citizen in the country and you try to testing the citizenship. You are American, you are Mexican, you are, okay? This is the idea. And you may be passed and you may be failed the testing. Okay? Now, let me set out the after the selection the testing point. I create my table. And the testing point, I have -1, +1, 3.5, and 5. Where's the factor involved in my problem? Well, involved in my problem, we have, it doesn't matter the order X. I don't know why I select X, because I consider it's easier. No? X minus 3, X minus 4. And the final total column. Super, very well. Well, this is a super easy column, it's negative, positive, positive, positive. Because actually it's the same sign. No? It's negative number when you put it in a negative, no? So this is negative, this is negative, this is negative, this is negative, and this is negative, but this is positive because you have even number of negative. Remember, the positive is not important. 3 negative and negative, 2 negative and positive. 1 negative, this is plus, this is minus, is negative. And no negative, this object is positive. I come back at the beginning. My problem say less than 0. That means the true guy is a negative. This is the true, and this is the true, and the rest is supposed to get false, totally false. Okay, so I like that way. I don't know you. I come back to the graphic part, to the line. Yeah, I highlight the interval case solution. The interval case solution, in my opinion, is this interval. Why? Because -1 passed the test. Look at that. True. Okay. And one more pass. 5 pass. But our interval start in 4. Remember, our interval is living in between 2 critical bars. When you have only one, because it's supposed to be infinity, no? Okay, and include the endpoint, no? No include the endpoint because, okay, okay, let me explain what's going on. See, we have equal sign here. But no, let me finish my example. Okay, it's not equal, entonces it's no include the endpoint. Entonces the final answer is from negative infinity, comma 0, paréntesis, paréntesis, union, or, oh, sorry, I'm making mistake here, right? Mistake. Okay, mistake. The mistake was, the true was this. This is correct. But this 3.5 que passed the test, true. Look at that. Sorry. Entonces the final answer is from negative infinity, comma 0, paréntesis, paréntesis, union, 3.4. This is the final answer. Okay. Let me spend only 2 seconds to explain what's going on. If my problem, what are the differences? See, my problem contains equal sign. Equal sign, equal sign, equal sign, equal sign, equal sign, equal sign. See, my problem contains equal sign because there's a combination, inequality and equation. The only, everything is the same except in the last moment in which this critical value and this critical value belong to the solution. This no. Why no? Because it's in the denominator. Denominator 0 is impossible. Okay? The 3 and 4 belong to the solution. So it's parenthesis here and 0 no. But this is bracket. Okay? Okay, the only difference is from negative infinity to 0, union bracket 3.4. Okay, guys, look at that. Let me summarize the idea quickly. The idea is when you have a rational, a fraction, two polynomials, you have two polynomials. Inequality, and this is less than or greater than or equal to, included equal to. Entonces, the endpoint que corresponde with the top part is included inside the solution. Never the critical value of the denominator. Never. Never. Only the top part. Okay, in this case, 4 and 3. Do you see that? You understand this or no? Guys? I understand. Wow. Okay, let me know. Let me know if you receive or no the review package. Okay, remember, the review package we start next class. Well, next class, I bring another example of this. And we start review package, get too long. Let me know if you receive or not. You can leave. If you receive, you say, Professor, I got it. And okay, I got it. So you can leave. Okay. Super guy. Okay, take care. Okay. And leaving guy. I have another class now.